Now let's actually look at a way to visualize both categorical and numeric data, or quantitative and qualitative data. So here on our sheet, we are talking about bar graphs versus histograms. So these are our first two types of data visualizations, and I'm going to go ahead and start with bar graphs. So bar graphs are actually a familiar way to visualize categorical data. And bar graphs display a bar for each category, and the bars are equally spaced and equally wide. And you can create bar graphs with either horizontal bars or vertical bars, depending on what you prefer. Bar graphs actually use the height of the bar to depict frequencies or counts. The widths actually don't mean anything, and a lot of times the bar graphs have spaces in between the bars. So puzzle 1 asks us to go ahead and draw a bar graph using the following data from the GPA dataset. So Wade, you have the GPA dataset pulled up?
I do.
Perfect. It says first find the number of sections in each category. Then go ahead and draw your bar graph. So Wade is importing the GPA data set, and I want to know how many sections are there in these 4 departments. We have Stat, CS, IS, and Math. And CS is computer science, and IS is information science. So Wade is actually loading the GPA data set. He did the classic import pandas as PD and then loaded the GPA data set as a CSV file into DF.
Yes, and then do you want the number of courses or students in the courses?
I want the number of courses.
So I'm going to aggregate by count to just count the number of courses.
Perfect.
And reset index. And then you want data for particular subjects, right?
Yes, so the first one is Stat.
So G at Stat is, I'm going to check where the G.subject is equal to Stat. And I see that in Stat, you have 750 courses.
All right, 750 courses. And that's throughout the 10 years, right?
The past 10 years, that's including this data set.
That makes sense. Next subject is computer science, or CS.
CS, we have 1,718 courses.
1,718 courses. Information science is next.
That's IS, and IS has 504 course sections.
Sounds good. And then lastly, we have math.
And math has 2,228 course sections.
2,228 course sections. So I have these categories: Stat, CS, IS, and Math. And so if I wanted to make a bar graph, we'll do this really quick. I would put 4 bars on my bar graph. The first one is for Stat. The second one is for CS, then IS, and then Math. And then the bars are going to represent, we're going to have them as tall as these number of sections. So we are going from, it looks like about 2,200 to 500. So I'm going to make my y-axis start at 500 and go up in terms of 500. So I have 500, I have 1,000, I have 1,500, 2,000, and then I'll go up to 2,500. So we'll start with Stat. With Stat, our number of sections was 750. So I'm going to draw a bar going up to about 750. And then I want to make sure that my bars aren't touching each other, because that is a feature of a bar graph. For CS, I had 1,718 as my number of sections. So I'm going to go up there. For IS, I had 504. And then for Math, I had 2,228. And there is my bar graph for the number of sections in each of these categories. So bar graphs for categorical data are super common. In data science, we definitely work with quantitative or numeric data a lot more. And so a common way to visualize quantitative data is actually called a histogram. And histograms are very similar to bar graphs or bar charts. Sometimes you'll hear these called as well. And unlike on bar graphs, the x-axis of the histogram is always drawn to scale. And it means something in terms of the numbers rather than a category. So histograms can help us see kind of the general shape of a distribution of data And there's two types that we're going to look at. The first type is called the frequency histogram. And a frequency histogram is very similar to a bar graph. The x-axis is your variable of interest, and then your y-axis tells you the frequency. Frequency histograms are very simple to interact with and to read. And Wade, I think you use frequency histograms a lot in computer science.
Almost all of the data science I do always wants to look at how many are in each category.
Exactly.
So we almost always use frequency histograms.
And then the other type of histogram is a density histogram, which I use a lot in statistics because with density histograms, we can look at percentages. Basically, the area of each block tells you what percentage of observations fall in that interval. So both the width and the height of the block can be used to determine percentages. And density histograms are, like I said, used a lot in statistics. One important note I have here is that in a density histogram, the total area of the blocks is always 100% or 1. So again, that helps with the percentages. And it just kind of depends on what you want for which histogram is more appropriate. But as a data scientist, you get to make that decision.
So besides the labels, are the histograms going to look differently?
So the histograms are not going to look differently, just the scale of the y-axis is going to be different because like I said, the density histogram, the areas have to add up to 100%, and the frequency histogram, the areas actually don't mean much and are going to be a lot bigger than 100%. So the shape is going to be the same for the two histograms, but the scale of that y-axis is going to be different.
Awesome.
And yeah, have fun with histograms.